Hi everybody. So this is just me kind of going over the remainder of the lab if you're still curious. So kind of just to look at it, from what we had done so far. You would have already done the distance versus time graph, which is what this picture looks like. And obviously you're answering the question. And we said the slope of a distance versus time graph is going to be our velocity. Sorry, my dog's kind of being annoying in the background. Then it says describe the motion of the bowling ball from the chart. So again, you're going to use your data. Is this a linear shaped graph? So does that represent its more constant motion, or does it represent a change in, is it inconsistent? Anyway, so kind of getting back to your data table, when you go to make your velocity or speed versus time graph, your speed becomes your y-axis. I'm really sorry, my dog she's really crushing me right now. She's just a little old thing and just wants my time and attention. So sorry, just give me 1 second to get her situated next to me. Anyway, so yeah, that's the y-axis, speed, and then time becomes the x-axis. I just realized I didn't even write the x. So yeah, you're gonna graph these. Keep in mind when you're actually making the graph, it's probably best to have your y-axis, depending on how big your numbers are, to either go like by 0.4 or 0.5, something like that, and for you to go all the way up. Remember, what you mark as a notch, right? So if I say, okay, this is 0.4, that means the next notch on the graph is going to increase by that same amount. So that means the next notch will be 0.8. So make sure that you have an origin, right? Because I noticed that some of us bypass that. The x-axis can go by 1, 2, 3, by ones, okay? Just keep that in mind. And then that too is going to ask a question. Sorry, I also didn't mean that. LOL. Turn my iPad on do not disturb. So hold on, let me write down here. So then it asks what's the slope of a speed versus time meaning. So again, this just means division of the x and y axis. So if we had speed versus time, and we know that slope is a change in y over a change in x, so we have a change in v over a change in t. We go to our handy dandy reference table, that represents acceleration, okay? So again, you're gonna use the same thing from your, from your data table. Was the line, roughly appearing constant? So basically, any ups or downs on your graph, those indicate accelerations. So the moment you change your speed, no matter if you're speeding up or slowing down, that indicates an acceleration. And then same thing, you're going to compare your graph to the speed versus time graph that was at the bottom. Okay, this is the same thing. So some of yours might look, depending on how your dots and your line of best fit, maybe your line of best fit, something that looked like that. It was barely a tilt. Regardless, right, both of these graphs would have been showing an acceleration. Okay, because again, an acceleration is just a change in the speed. And then when it got to the back, right, hopefully we did this together as a class. We did the graph together, and you have to make sure that you explain, right? So that's why it's really important when you have these D versus T and velocity versus time graphs, you read it as time increases, and then you pay attention to what happens to the y-axis. And after that, then you try to relate those graphs back to the 3 conditions in physics. So it's either at rest, at constant velocity, or you're accelerating. Okay, so you're trying to match the graphs. But the part that I think we needed the most help on was this graph part, right? It was speed versus time. So we had 1, 2, 3, 4, 2, 4, 6, 8, 10. We had some sort of line that looked like this. Okay. And so the first part said calculate the acceleration. And let me write my x and y axis so we know what's going on. So in order to find this, you have to take the slope. It said from 0 to the first 3 seconds. So I would say, okay, my point, and my graph kind of stinks, so like the point was 8, 3. Excuse me, 3, 8. And then you also include the origin, 0, 0. So we know that slope equals delta y over delta x. In this case, we have a change in speed. So I would have 8 meters per second minus 0 meters per second over 3 seconds minus 0 seconds. Obviously, you would get some sort of number. Remember, the units are meters per second squared now, okay? Then, for the next part, they wanted to know the total distance. Now, this was a little tricky. And for some of you, I might have made a mistake. So if I did, like, it's not on you, it's on me. So no big deal. So if they're looking for total distance, that means that they're actually looking for us to analyze exactly when this graph kind of ends right there at the 10. So if you drop a line here, it was past the 3.5 mark. So we said like you could estimate like definitely like 3.6 to like 3.8, we could say, was like the range that you could use for the seconds. So you might have like different answers here. But when you drop that line, oops, we have a whole bunch of space right here. And remember, this is not a right triangle in the sense that you could use Pythagorean theorem. It's a graph. So when you're using a graph, it's either you're taking the slope of something or you're doing the area. Okay? So in the equation that has v equals d over t, if I wanted d isolated, I would have to multiply t on both sides, and I get d is equal to v times t. This multiplication tells me I have to use the area. So I'm going to multiply the x and y axis. What's really important, again, is that you have a triangle. So that means you have to know the area of a triangle. So area of a triangle is 1/2 base times height. So the base, like I said, it goes a little past 3.5. So you could say like 3.6, 3.7, 3.8. So you have 3.6 seconds, and the height of it, goes up to 10 meters per second. So again, you're going to have a range of answers here because this could have been from 3.6 seconds to 3.8 seconds. So it really doesn't matter, okay? And then that value, whatever that number is, it's going to have the unit meters, and that's going to represent your total distance that we acquired from the graph, okay? So I hope this helps. Have a good night.